we will go into atoms and elements. See, in nature actually the the smallest particle, like see, suppose yeah, let it be this paper itself. So I am tearing. Okay, let it be. I teared it, and then again teared it, then again teared it. So very small particle, like this is, I reached up to here, right? Again, if you are cutting, okay, it will go into the level of an atom. So, of course, molecules, and then if you again split molecules into its respective components, you will go into atom. Okay. So atoms are the smallest particles. I mean, like the most fundamental particles on the nature is called atoms. See, actually the word atom, it has come from atomio. So this means, atomio means something which you cannot split further. So you will split, then you will reach into a level in which there won't be any possibility of splitting it further. Okay. So this particular status is called atom. Now, what I have to tell you is, okay, see, there are many atoms are present in the nature. See, let it be sodium, oxygen, and nitrogen, and then hydrogen. See, every atom, it is identical in nature. Okay. See, and see, for example, the hydrogen atoms. This hydrogen atom cannot be similar to oxygen atom. So, for example, like hydrogen and nitrogen. Okay, this is molecule. Yeah, two nitrogen atoms combine to form a molecule. Okay, two hydrogen atoms combine to form a hydrogen molecule. See, these nitrogen atom cannot be similar to hydrogen atom, and vice versa. Hydrogen atom is not going to be similar to nitrogen atom. Okay, and if I tell you about the nature of atom, see, atoms are, most of the space within the atom, it is empty. See, most of the mass of the atom, it is concentrated within the nucleus. So this is atom. This is actually nucleus. Okay. So you see, like this space is empty, this space is empty, this space is empty, this space is empty, this space is empty. Okay. And okay, this space is empty, and most of the space within the atom, it is going to be empty in nature. Okay, and the most of the mass, it is concentrated inside the nucleus. Okay, and if I tell you very precisely, suppose you are taking a small football, you are keeping in the middle of a big big football ground. So that is what an atom is. This is a football. This is this big circle. It is nothing but a football ground. Like there is the entire mass of the entire mass, it is getting concentrated in the middle of the atom, what we call it as that is what it is. So you should know, if you consider an atom, the most of the space inside it is empty, and most of the mass, it is concentrated within the center of the atom. Okay, and now actually there are many elements. I mean, like there are many elements. You can say there are many atoms, and generally, like these atoms, we can also call it as elements. I mean, like it depends on the circumstances. See, there are many elements present in the nature. There are many types of atoms are present in the nature. For example, yeah, one element is sodium. Okay, and the next element is potassium, and of course there is oxygen and hydrogen and nitrogen. Okay, see, one thing you should, sorry, this is not an atom, this is molecule. One thing, in nature there are around 90 elements are present. 90 elements are present, but if you see the periodic table, you can see more than 110 elements are there. So this 90 elements that is present in the nature. Common elements you would be familiar: oxygen, nitrogen, hydrogen, and argon, and then helium. Yeah, of course, iron, copper, nickel, cobalt, potassium, sodium. So many elements are present, and there are some artificial elements are also present, which is not available in nature. We have synthesized it in the laboratory. Of course, these artificial elements, it is very unstable. If you keep it here, its life will be just around, you can say just around maybe 1 hour or like some seconds. Some it will last for days. Okay. So that is, in fact, those elements are radioactive elements. So these artificial elements, these 90 elements are natural. This is radioactive elements. Okay. So remaining elements, remaining roughly around some 20 to 30 elements actually, that is radioactive, I mean like that is artificial elements. So those are very reactive and you cannot see that in the normal conditions. Okay. And these elements, we give them some symbols. For example, for oxygen, sometimes these symbols will be for oxygen it is O, hydrogen it is H, nitrogen it is N, for argon it is Ar, then for helium He, then for iron it is Fe, Cu, copper, nickel. Then of course for potassium it is K. Then you may wonder why there is for potassium it is supposed to be PO, or else it could be P, or else it could be say like P or like POT something, right? Instead of that we are giving the name, we are giving the symbol K. Why? Because sometimes like the Greek or Latin name of some elements will be for potassium it is Kalium. In that sense like we are putting the name K. For sodium it is not S, it is not SO, it is actually Na. So this is actually come from the word natrium. Okay. So the elements, the elemental symbol we usually give because we don't want to confuse, it would be easy instead of writing some long chemical reactions with the sodium or something with its word, we can use the symbol and then we can write. Okay, so this is it about its symbols. And how many of you know how many symbols you know? See, for nickel it is Na, for titanium it is Ti, then for zirconium it is Zr, hafnium it is HF. Of course, as the time passes, you will come to know what elements are there and what are their symbols. Okay, we will see the picture of periodic table. You can see the picture of periodic table for a while. So what you have seen in the periodic table, see, I will draw the periodic table just for a representational purpose. Anyway, you have already seen the periodic table. So it comes like this, right? So below there are two blocks. So yeah, there are many elements. Of course, you will learn about periodic table very nicely in your successive classes, but I don't want to go very deep into that now. Okay. So here also some elements. So see, the for your understanding purpose, this is the first group actually. This vertical columns in the periodic table, we call it as group. And this horizontal columns, so see from here to here, okay, horizontal columns we call it as periods. So this is first group, second, third, 4, 5, 6, 7. In this first block there will be 2 groups, and from here to here there will be 10 groups. From here to here it is 13 to 18 groups. Okay. So this is the nature of periodic table. And one thing you have to know is, see, this is first group. There are I will write the name of first group: hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. So these are the elements in the first group. Or else if you ask me to write the elements in the 13th group, I can write boron, aluminium, gallium, indium, thallium. Okay, so these are the elements in the 13th group. Okay, So one thing you have to know is actually this one thing, a few things you can understand when you see the elements in the periodic table. I mean in the same group. See lithium, sodium, potassium, rubidium, cesium. Okay, these elements, if you put it into water, it will explode because it releases hydrogen gas. In the same way, all these elements, these are metals. Again, these are very soft metals. You take a knife and you try to cut the sodium, it will break. Same way you take potassium, yeah, you can cut it and that also shall break. Okay, so you can cut using a knife. And rubidium, that also it can be broken. Done. Okay, and the same way, like this element here, beryllium, magnesium, calcium, strontium, barium. Okay, so these elements also, these are actually, these are elements it forms alkalis. And again, all these elements, beryllium, magnesium, calcium, strontium, barium, these are actually strong alkalis. And these are also soft metals, these are also metals. Okay, so the second group also metals, alkali formation. Okay, and what else I can say? These elements, of course, if you show it into the flame, it will show color formation. Okay, so for example, calcium, it shows some brick red color. Brick red means like the some brick we uses for construction purpose. No, the same color calcium will be showing. So this is the nature of these elements. Okay. So one thing you can understand from this the periodic table is the elements in the same group, it shows something, almost some similar properties, similar characteristics. Elements in the first group also it shows some similar properties, similar characteristics. Okay, so this is one of the peculiarity. And now yeah, if you see here actually instead of here and yeah, it will be normal line, but from here and there will be some zigzag line, it will be there actually, because boron it is a non-metal, aluminum it is a metal. So the metal and non-metal, it can be distinguished and it can be separated from using the zigzag line. Okay, and now yeah, there are few questions. What is an atom, an element? Of course, an atom, it is the simplest form of matter, and element actually by definition, what you can say is, an element, like it contains only one type of atom. Okay, it can be a group of atoms. An element, it contains only one type of atoms. Second question is, if you could look inside an atom, what would you see? See, if you see inside an atom, see, this is most of the space inside an atom, that is empty. As I already told you, in the middle of an atom, so this is actually, this is in fact nucleus, and of course electrons, it shall be revolving around the nucleus in some fixed path. We can call it as orbit. Okay. Next question is, the symbols for some elements come from their Latin names. See if you can identify the element whose Latin name is natrium, ferrum. Yeah, natrium, it is nothing but sodium. Ferrum, it is nothing but iron. Come from the word ferrum. Plumbum, lead. Argentinum, argentum, so it is silver. Okay, and which element has the symbol Ca? Ca is for calcium. Yeah, this is an element, very important element. It is present in our bones and all. And then Mg, magnesium, and they are asking N, it is for nitrogen. Okay. And another question is, see if you can pick out an element named after the famous scientist Albert Einstein. Of course, not a very easy question. You have to thoroughly see the periodic table. If you happen to see the periodic table, almost in the down, okay, yeah, in the atomic number 99, there is ES. Okay, that is nothing but Einsteinium. The name of the element is called Einsteinium. So, why the name of the element is called Einsteinium? Because it has come from the name of scientist Albert Einstein. Okay. From the periodic table, name 3 metals. Yeah, 3 metals I can name. The first element itself: beryllium, magnesium, calcium, strontium, iron, nickel. You can name any number of elements. 3 non-metals. Non-metals. See, one thing, if you happen to see the periodic table, okay, you can understand the number of metals, it is much higher in number, okay, and the number of non-metals, it is very less in number, okay. So the number of non-metals will be roughly around 20, but the number of metals are most in number. Non-metals, picking up the non-metals, it is not as easy as finding the metal. Yeah, I can tell you one non-metal is a boron. Next one is nitrogen. Yeah, another non-metal, it could be lead. Sorry, instead of lead, the best example is oxygen. And all inert gases, let it be argon. So this is a non-metal definitely. So these are the one. Okay, and yeah, and from the question is incomplete. Actually, from the periodic table, name 3 metals, 3 non-metals that you expect to behave in a similar way. Simple thing, you take the elements from the same group that will be behaving almost in the similar way, because beryllium, magnesium, calcium, strontium, it behaves in the similar way. These 3 are metals. In the same way, like non-metals, this is a little bit a tricky question. See, non-metals, the last 18th group elements, okay, helium, argon, then krypton, so xenon. So these elements that behaves in the similar way, because these elements doesn't react. These are all gases, and it is known as inert gases due to its inactivity. So this is the nature actually. These elements, it is very inert and unreactive gases, and it is non-metals also.